All right, good morning, everyone. Can you grab a last cup of coffee and come on in, please? I think some people's calendars said 9 o'clock, others said 8:30, so we're splitting the difference and going about 8:45 in the traditional bureaucratic log rolling tradition. My name is Dennis Blair. I'm the Chairman and CEO of Sasakawa Peace Foundation USA. We're one of the two co-hosts of this event today, and I'd like to welcome all of you and thank you for attending, especially those of you who have come great distances from Japan and elsewhere. I know that people who are in the rare metals business are used to traveling around the world and to strange places, and their body clocks are generally out of sync, but at any rate, thank all of you for coming. I think that this conference that we're holding today is really a unique gathering of people with so many different insights and so many different experiences and so much different knowledge about this area of rare metals. We have businessmen, academic researchers of the topic, consultants, government officials, ex-government officials, and I think the combination of knowledge that we have in this room is unique, and we hope to take advantage of all of it in the series of panels and then the more private workshops which we will hold afterwards. So throughout the course of the day and tomorrow, we will share perspectives on the risks in this area, the requirements, the future, the opportunities. We'll talk about supply chains, potential future uses for rare metals, the resiliency of this business area, and in fact, the whole range of issues involved in it, with an emphasis on looking for ways that the area can be made better by a combination of public and private actions. Our motivation at Sasakawa USA is pretty simple. Our mission is to advance, deepen, and widen the U.S.-Japan. Before introducing our co-host, I'd like to acknowledge a few of the other groups that helped us put this together. There were several who helped get the word out to those who might be interested in the conference. There was the Minor Metal Trade Association, David Abraham's Technology, Rare and Electronic Material Association, Japan Society of Northern California, led by Larry Greenwood, Mark Fabry of the Philanthropic Capital Group, and Sharon Burke of the New American Foundation. So thanks to all of you who lent us your mailing lists, who made calls to get the word out, to reach the audience of those who are not only interested and knowledgeable about this subject, but should be interested and more knowledgeable about the subject. But I think we have a terrific group here today. We certainly look forward to learning, to sharing ideas, and to coming up with some notions that would make the area better in the future. And now let me turn to my co-host, the Dr. Hoshi, who runs the Shorenstein Center here at Stanford. Takeo.
Thank you, Admiral Blair. And it's my pleasure to welcome all of you to this conference on critical resources, co-organized by Sasakawa USA and Asia-Pacific Research Center here at Stanford University. I'm Takeo Hoshi. I'm the director of the Japan program, which is located, or which is inside the Asia-Pacific Research Center here at Stanford. And we share the Japan program, share the goal with the Sasakawa USA in trying to deepen the ties between US and Japan and try to find the ways to solve some of the common problems we face, that both countries face. So I'm very glad to co-organize this conference with Sasakawa USA. I'm an economist by training, and I do research on finance and banking mostly, so I know very little about issues around critical resources or minor metals. But I study Japanese economy, so I vaguely remember there was an alleged incidence of rare metals embargo by China several years ago, and that caused a serious concern among Japanese business and also policymakers. So I at least understand that we are talking about very important issue for the Japanese economy today. So I look forward to learning more about the issues from the experts that are gathered here in academic, business, and policy areas. So I'm looking forward to this conference. And I'm especially glad to organize this conference with Sasakawa USA because although this is my first time to co-organize a conference with Sasakawa USA, but the Japan program at APARC in the past organized a couple of events with Sasakawa Peace Foundation in Japan, which is a parent organization or a corresponding organization in Japan of Sasakawa USA. And we held a conference one on energy issues and the other on innovations. And for each, we worked with the Sasakawa Peace Foundation and compiled a nice report, which I brought here. One on energy issues and one on innovations. And I think we still have some copies of these reports available. So if you are interested, please let me know. And also, you can find the annual report of Asia-Pacific Research Center, APARC, on the outside. So please make sure to pick one up. I said I know very little about minor metals, but to prepare for this conference, I read a book written by David Abraham, and who will speak next to set the tone for this conference. And almost everything I know about critical resources, I have learned from David's book. So let me hand this over to David, who will set us in the right direction for this conference. Okay. David.
Thank you very much for the introduction, and glad to hear that the book itself was a resource to you. About 20 miles from here, and 10 years ago, almost to the day, Steve Jobs walked up to the stage at Macworld, and he had a bold claim that he was going to reinvent the telephone. And he introduced iPhone. Now, there were many breakthroughs of this particular product, but one of the most transformational was that he banished the keyboard. He got rid of those lettered toggles that we used up until that date. And he said that he was just going to make a glass screen. And that glass screen would be enabled with something that he called multi-touch. And that's the tapping and dragging that we now take for granted when we use our smartphones. Back then, he said this new technology worked like magic. Now, to many of us in this room, we know what that magic was. That was indium, a transparent conductor that basically allows your fingers to operate the apps. And when we look back, we realize, wow, it was that transformational breakthrough that he discussed, that he alluded to. There were so many things beyond the apps. But really, what was the transformational aspect was it was that multi-touch screen. And really lost in the hubbub of great design was something happening that was more profound, more basic, and more elemental. It's that half the periodic table is in that phone, making it work. Each element or each metal working something very specific. And in fact, I would argue the ability for us as a society to put the materials together, the metals coming from different countries, in one product is as impressive as the phone itself. And what Steve Jobs did was do something more than reinvent the phone. He unleashed the power of the periodic table to the masses, the power of rare metals, and he brought forth the new era, the era of rare metals. Now, for many of us, or many people in the world, they don't have a good understanding of the resources that make the products. Many of these were chemistry curiosities just 15 or 20 years ago. People didn't even know how to pronounce them. Dysprosium, neodymium, tantalum. There's no ingredients list on the iPhone as to what makes it. These were just words that made no sense. And even for the companies that relied upon the power of these rare metals, they had no idea what was in them. One of the challenges is that the products that we use today, in many cases, perform the same function that the products did of yesteryear. Look at the light bulb. What they do now is still the same function. They illuminate a room. But the one on the left is drastically different in its resource needs than the one on the right, with gallium and rare earth phosphorus. They're more akin, our technologies today are more akin to a computer than they are the light bulb that we used just 10 or 15 years ago. And as we switch to new technologies, as we reduce our reliance on oil and gas, and the sun and the wind create power to create energy for our vehicles, we're trading resource dependencies. And we're not trading the oil and gas for the wind and the sun. We're trading the oil and gas for the cobalt, for the graphite, for lithium, for a whole set of resources that power the products, especially the green ones, of tomorrow. And in the same time, we're unleashing a whole new set of economic, environmental, and geopolitical risks and ramifications that we truly need to understand. And the beginning of today's conference will help us discuss some of these issues. Now, the question is, what are rare metals? And some people call them strategic materials, critical materials, minor metals. We're roughly talking about 40 to 45 elements on the periodic table. And they have some very unique characteristics that make them very different than traditional commodities. The first and most important distinction is that most of these materials aren't mined for themselves, that they're mined as byproducts. And that's an important distinction, that just because the resource is in the ground doesn't mean it can be brought out. And one of the challenges that we'll discuss over the day is that this byproduct nature makes it so that even if the demand for a certain material will rise, it's not clear the supply can rise likewise without a change in the processing or the production of the primary metal. But there are a number of other characteristics, and I think at this point it's important to understand, for those who aren't in that space, is that rare metals shouldn't necessarily be confused with rare earth metals or rare earth elements. Rare earth elements became famous in 2010, as the professor was saying, during a conflict between Japan and China, when China withheld access to these resources. But rare metals is a larger group. And what distinguishes them is not that they're geologically scarce or rare, but their production is. Oftentimes, we're talking about the hundreds or thousands of tons annually that are produced and consumed, compared to copper, where we're looking at millions of tons, or 18 million tons. They're also used in very limited quantities, or recently have been used in very limited quantities, in the grams per product, although that is an important distinction that's changing. And because they're produced in limited quantities, often one country, and in some cases one mine, dominates the production. The materials themselves are tailored to end uses. So that makes it very difficult to understand what the prices are. There's no exchange that lets people know what the price of dysprosium is. They're traded in more backroom deals. Another important aspect is to understand the processing is key. It's not a question of whether we have the resource in the ground. It's a question of, can we economically produce the right material in the right grade at the right time with the right economic and environmental price. And what we see here are powders, rare earth powders. And it just shows that we're not even necessarily using the metal, just a somewhere in the process of forming the metal. So to get the mineral into usable form is challenging. And in the case of rare earths, it takes years of mixing acids and heats to find the right balance to produce something that's economic and can hit the market. And because of permitting and this time to set up a processing line can take years, the whole process to set up a supply line can take 10 to 15 years. But I think it's most important to think not just of the metals themselves, but the properties they have. And one of the things I like to discuss is that these materials have superpowers. They have something that's very unique that makes it almost irreplaceable in some of the applications. Rhenium in jet engines with its high boiling point allows the engine to get hot where it couldn't if it didn't use rhenium. Titanium, it's light and strong, similarly used in aviation. So there are unique challenges and risks to this market that are different than traditional commodities. So the question of demand, where is it coming from and why is it increasing? And I think we have to understand when we look at these rare metals, they're just recently being used. If you were to take two time periods, from the beginning of time, when Adam and Eve were walking the earth, to the late 1980s, and between the 1990s and today, you find in that latter time period, we've used 4 times as many rare metals in that time period than we used from the dawn of time to the 1980s. It's because the products that we're using today are becoming lighter, smarter, more powerful, and those rely on these unique superpowers that we were discussing before. The new uses are really going to be driven by these 3 areas: green technology, the spread and use of rare metals in gadgets, and our defense applications. We're using more rare metals in more products. And this year, since Steve Jobs introduced the iPhone, we're going through 1 billion smartphones a year. We're using a lot more products that are enabled to be connected that rely on rare metals. In 2010, we had 12.5 billion devices attached to the internet. That's going to be roughly 50 billion in 4 years. The number of the devices that are connecting rely on these powerful properties of rare metals. And it's not just we're using more of them, we're churning through them far faster. The life cycle of our products have shrunk 2 to 3 years in some cases for these laptops. And in fact, you can't even tell the difference between the two, but there is a difference. One is a product that comes 3 years later. And because we're churning through materials faster in these rare metal-laden products, the life cycle of the commodity has shrunk. Back in the 1970s, commodities lasted 5 or 10 years. Now they're just lasting just a couple. And there's a major change coming. And it's what I alluded to at the beginning. We used to use grams of material per product. And you can see that's a telephone battery on the top. But as we switch to green technologies, as we switch from batteries that are used in phones to batteries that are used in grids, we exponentially increase the resources that we're going to need, which can create wonderful opportunities, but again, risks of supply. The developing world is using products in ways that we haven't here. I met a gentleman named Sessa in Jakarta. Well, actually never met him. I just tweeted and texted to him. But he made $300 a month, and he had a desktop, a laptop, a mobile phone, a game system, a television. The money that he was using was going towards technology. And it's something that we're seeing, that I see quite often being in Indonesia. But there's something also greater at play. Just as these developing countries went without setting up an infrastructure for their telephone systems, I believe the advancement of green technology will make it so that we can distribute power in ways that we haven't thought about but will rely heavily on rare metal applications to make it possible. So what are the challenges really to secure supply of rare metals? And some of them are very similar to securing supply of different materials. And this is a chart that Professor Tom Gradel had worked on that talked about ore grades dropping. And this is a chart from Australia. And my point to bring this out is that when ore grades drop, that means you have to bring up more material, more of the earth, to produce the same amount of product, which has environmental implications, but it also has cost implications. So it's increasingly harder to find the right resources in the ground at a high enough concentration. People discuss recycling as it's a panacea to all commodities, in the sense that we just recycle it and we put it in a garbage can. But the challenge to recycling is vast. And mostly, it's getting the materials to the right place. What we find is that most of the materials that end up in our house don't end up to the right recycler. And then when they do end up to the right recycler, we're only recycling 2 or 3, maybe 4 elements, 4 metals out of these products, out of the 60 some odd that are in them. The challenge is vast to extract resources from man-made ores. So what we find, and again, returning to Professor Gradel's studies, is that recycling rates of a lot of these rare metals are below 10%, creating challenges to making more of a circular economy. Likewise, looking at the structure of just the rare earth magnet industry, it is so complex to put a magnet together, and that's just one piece of material that is in an air conditioner, for example. And what I use this slide to show is not that it's completely clear at this distance, but the point is that it's not clear at this distance, and that changing supply lines is a challenging thing when you have to ensure that the materials that you're buying have very specific properties and are certified, because these superpowers go away if the processing is done incorrectly. And finally, the challenges of finding new resources. As the ore grades are dropping, we're having to go to more remote locations. And as people become wealthier, as developing countries become wealthier, as developed countries start developing a higher environmental tolerance, they don't want mines. And the challenge is paradoxical. The resources it takes to make a green technology come from the ground, and they take vast amounts of processing. So there has to be a trade-off somewhere, but we have to understand and understand how we address these risks, the environmental risks, when we need a world that's based on more of a green economy. And finally, this may be the biggest risk to certain people in this room, where the resources either come from or processed. And most of these minor metals and rare metals, critical materials, come from or produced in China. Some are from Brazil, South Africa, Australia. And because these countries have a more monopoly-like position in these markets, change in geopolitics, trade patterns, a natural resource disaster create great risks that end users need to address. So the question is, well, what keeps me up at night when I look at these resources? And I think it depends on which me you're talking about. If it is me, the one working at a company, I would be very concerned about this. Now here is a chart that talks about the consumption, the spread of technologies throughout society. And what you see looking at this chart is that historically, new inventions don't proliferate so quickly. And this is a proliferation of products in the US. But that's changing. Steve Jobs' iPhone, the tablet, these products spread around the world far faster than any any other product in history. Within 4 years, 6% of the world owned a tablet computer. Likewise with the smartphone. No product in history, not the radio, not the air conditioner, not the refrigerator, went around the world so quickly. But it goes back to the concern is the resource supply lines. They're taking 10 to 15 years to set up. So we're coming to a point where there's this mismatch between the ideas and dreams of producers like Apple, the green world that environmentalists push, and the reality of getting the right resource in the right grade to the right location at the right time. So what does that look like? And I'm using a chart from Simon Moores, who will be speaking later today, to talk about that growth pattern. And this is really for graphite use in batteries. In 2011, we're using under 45,000 tons. But you can see the increase as we start producing more and more vehicles, as we go increase the production of vehicles in 2015 from 700,000 a year to 2025, which is not on this chart, which will be in roughly the neighborhood of 8 million a year. The increase of battery use will drive demand. And it's not a question, again, of is the total resource there. It's the right resource that is needed to make the batteries that we need. If I were a Japanese component manufacturer or a Japanese tech producer, I'd be concerned about this. This is China's Made in 2025 strategy, a great strategy to really take China forward to become a producer. Beijing itself is tired of assembling iPhones and making Christmas lights. The idea is to build products end to end in the country. And they want to produce 75% of the components that are in the products, especially in these industries. And that would be a massive change. That would be bringing the component manufacturers either to China or building them within China. And that would hurt industries in Japan, Korea, and Germany. And the fear here is that China would use resources as a leverage to build these industries in the country by either encouraging people to come over or withholding them in some way. If I was a US military planner, I'd have similar concerns, not necessarily just for the particular resource, but the whole supply line, that components that are made of rare metals are made in another country. And that challenge is brought out during a time of conflict or a time of geopolitical stress. The concern is, will the materials be there when they need them to be? But there are other if I was an environmentalist, I would be concerned about the decreasing ores and the larger footprint that minor metals have. The processing uses far more energy and has far more waste than traditional commodities. If I was a President-elect Trump and I were thinking about the future of manufacturing here in the United States, I would be concerned about our geologists, our mineral scientists, our material scientists. We don't have what we once did in this country. So when I travel to China and I go to a rare earth conference, I'm surrounded by 400 scientists all focusing on one aspect of rare earths. In 2013, I went to a critical materials conference focusing on all materials, and we had 140 people wondering what's going on in China. And the gains from the production of these materials goes to the countries often that produce them. So my hope here today was to set the scene of certain risks that we may be seeing in the market. And the question is how do we address them? 100 years ago, we jumped into oil and gas without knowing the risks and ramifications. Our next industrial era requires us to understand what the resources are that takes it for them to move forward. And those are rare metals. So I'm very excited about the people in this room today. Professor Tom Gradel, Simon Moores, Toru Okabe. These are legends in the field, and each bring an aspect, whether it's an industry focus, an academic focus, a trading focus, that's critical for us to be able to put the risks together and have a solid conversation. So I thank you very much for the opportunity, the Sasakawa Foundation, Stanford University. I think the event you put together is wonderful, and I look forward to the panels. Thank you.